Good morning. I hope you are doing well. Today we are going to talk about matrices and elective mathematics. This topic is very easy. It's not difficult. All you have to do is to understand the rules or the principles that guides each operations, and if you follow such principles and rules, you'll be okay. So the first one thing you need to understand about matrices is that it's the arrangement of items. It can be numbers, can be letters. I hope you get it in brackets or parentheses. Now, if you look at this is a matrix. It can be written in this form or it can be written in this form. Now, one thing you should know about matrices is that it has rows and columns. Rows are the horizontal pattern and the columns are the vertical pattern. So if you look at this matrix, it has first row and second row, meaning that this matrix has two rows. If you look at this matrix, it has first column, second column. It means that this matrix also has two columns. So this is a 2 by 2 column. Sorry, 2 by 2 matrix. This one is the same thing. One row, one column. So this is also a 2 by 2 matrix. I hope you get it. You can have other forms of matrix, but basically this is a 2 by 2 matrix. Now, without wasting much time, let's talk about the operations on matrix, which is the addition of matrix. So let's say we have been given two matrices. We have A and B, and I have been asked to find the summation of A and B. That's A plus B. What are you going to do? So we add the two matrices, but we add corresponding components. What I mean by adding corresponding components is that you see this first matrix. If you look at the first row, the first element is A, right? If you look at this matrix to the first row, the first element is E. So they are corresponding components or members. So you add them. So this first matrix in the first row will add to this. This second matrix in the first row will also add to this. To come to the second row in the first matrix, this one to add to this, and this one to add to this. So looking at the position, they correspond. So like we add corresponding elements in their corresponding positions. You get it? So that's how we perform the addition. So you can see A will add to E. That's what I've done here. A plus E, then B plus F, then C plus G, which is this, and D plus H. You've seen it. So all you have to do is just add the corresponding components, and that's it. It's not difficult. So let's take this for example. We have the first A to be 2 1 2 2, B is 5 4 2 3. So now to add corresponding components, I'm going to have 2 plus 5. Now give me, so you've seen it, 1 plus 4, which is this, 2 plus 2, which is this, 2 plus 3, which is this. Now 2 plus 5 will give me 7. 1 plus 4 will give me 5. 2 plus 2 will give me 4. And 2 plus 3 will give me 5. So that's it. Very simple. We just add corresponding components, and that's it. Now let's solve another question too. So you are saying that if m is equal to negative 2 4 1 6 and n is equal to 6 negative 2 4 2, find m plus n. So you are looking for m plus n. So how are we going to do it? The same thing, we add the corresponding components. So this is the first matrix m plus the second matrix is n. Now the corresponding component, this one corresponds to this. You've seen it. So negative 2 plus 6. This one corresponds to this. So that's 4 plus negative 2. This one here corresponds to this. That's 1 plus 4. This one here corresponds to this. That's 6 plus 2. You've seen it. So now negative 2 plus 6. You are owing 2 cedis and you are paying 6 cedis. You be left with 4 cedis, right? Which is positive. So negative 2 plus 6 is 4. 4 plus negative 2. Whenever you have positive and negative, negative is stronger. So it means the operation sign here will be negative. So it's going to be 4 minus 2. That'll give you 2. Now 6 plus 2. That'll give you 8. 1 plus 4 give you 5. So that's it. Very, very simple. So that's how we perform the addition in matrices. It's not difficult. It's very, very easy. So our next topic, let's talk about the subtraction. Now we are talking about subtraction of matrices. It's the same thing as the addition. We subtract corresponding components. You get it? We subtract corresponding components. So if you have this matrix A, which is A, B, C, D, matrix C, which is E, F, G, H, and you are being asked to calculate for A minus C. So A minus C here, we subtract corresponding component. So this is A minus what? E, which is this. Then you have B minus F, which is this. And we have C minus G, which is this. And we have D minus H, which is this. One thing to know about matrices is that they are not commutative. A minus C will give you different answer from C minus A. You get it? So look at something. C minus A, you mean at this point, the phase we are subtracting A from C. You get it? So the E starts with what? The C starts with what? E. So E minus the first matrix is A. You're going to have F minus what? B. You're going to have G minus C, and we have H minus D. So in matrix A minus C is not the same as C minus A. Simply put, subtraction is not commutative in what? Matrices. Now let's solve some examples. We have, let's say have x is equal to 2, 4, 5, 6, and y is equal to 1, 3, 2, 4. First question is find x minus y. So we are subtracting the matrix y from x. So this matrix x, which is 2, 4, 5, 6, minus which is y, which is 1, 3, 2, 4. The same thing, we subtract corresponding component. 1, 2 here correspond to this. So I'm going to have 2 minus 1. 4 here correspond to this. 4 minus 3. 5 here correspond to this, which is 5. 5 minus 2. 6 here correspond to this, which is 6 minus 4. Now 2 minus 1 will give you 1. 4 minus 3 will give you 1. 5 minus 2 will give you 3. 6 minus 4 will give you 2. So that's it. It's not difficult. It's very, very easy. Now let's find y minus x. So in this case, we are subtracting the matrix x from y. We are subtracting the matrix x from y. You get it? Now the matrix y is what? 1, 3, 2, 4. And the matrix x is 2, 4, 5, 6. So we're going to have 1 minus what? 2, which is this. 3 minus 4, which is this. 2 minus 5, which is this. 4 minus 6, which is this. 1 minus 2 give you negative 1. 3 minus 4 give you negative 1. 2 minus 5 give you negative 3. 4 minus 6 is negative 2. Very, very simple. you see that the value that we had for x minus y is different from y minus x. This tells you that subtraction in matrices is not commutative, they're not the same. Let's solve another one. I said let m is equal to 4, 5, 3, 2 and n equals 2 minus 2, negative 1, 4. Find m minus n. So in this question we are subtracting the n from m. So the matrix m is 4, 5, 3, 2 minus 2, negative 2, negative 1, 4. So let's do the subtraction. This is 4, is correspond to 2, so 4 minus 2. 5 is correspond to negative 2, so 5. But because this is negative, this is negated, and we're also subtracting it, negative will give you positive. Do you get it? Because this is already negated and we're also performing subtraction, negative will give you positive, negative will give you positive. So 5, instead of 5 minus 2, go to 5 plus 2. Okay, I'm going to have 3, this one 2, because it's negated and also perform subtraction, become positive. So 3 plus 1, and we have 2 minus 4. Now 4 minus 2 give you 2, 5 plus 2 give you 7, 3 plus 1 will give you 4, and 2 minus 4 will give you negative 2, because this is smaller and this is what bigger. So if you subtract a bigger number from a smaller number, we have negative. So 2 minus 4 will give you negative 2. So that's it about the subtraction.